Okay, so my camera app crashed right as I was looking at it, so luckily I did not get very far at all. Alright, so example 3 from the notes, here it is. We've got a survey of 400 customers at an ice cream shop. So 400 customers were surveyed, and they were asked about 3 different flavors of ice cream. So this is much simpler than a real world problem, because in a real world an ice cream shop has like dozens of flavors. But we're just going to show what can happen with just 3. So we've got chocolate, vanilla, and strawberry ice cream. And we've got the number of people that strictly like, or well, not strictly like, but number of people that like chocolate, number of people that like vanilla, strawberry, people that like vanilla and chocolate and strawberry, chocolate and strawberry, and then the people that liked all 3. So we want to construct a Venn diagram for this situation and answer some questions about it. Okay, so let's say I've got my universal set. Always need a universal set. Then let's say that this is chocolate up here, vanilla, and strawberry. Alright, so what we could do is just start arbitrarily writing numbers everywhere, because it looks like we've got all of the sets already written down, like 201 like chocolate, so write 201 out here, and 100 like vanilla and chocolate, so you write that in there, but in this spot, but that would not be correct. Okay, that would not be correct. Why is it incorrect to write 201 right here? Why would that be incorrect in this spot? Because this spot right here is not the total number of people that like chocolate ice cream. This spot where I'm pointing is reserved for the people who like chocolate ice cream but don't like any other flavor. That's the difference. And for another example, right here, this spot, the intersection, it looks like just the intersection of chocolate and vanilla right here, right? So why not write 100 right here? Because this spot in particular right here is not reserved for the people that like chocolate and vanilla altogether. It's reserved for the people that like chocolate and vanilla but also don't like strawberry. So you see, each of these spots is more distinct than you would think at first, right? So the way to do it is to always start from the very center, from the most exclusive spot. So 18 people liked all 3. That's what we start with, right there in the center. Now, this spot, let's say this spot here, the one I was just talking about, chocolate and vanilla. The number of people who like chocolate and vanilla is 100. So what do I write right here? Not 100, right? This whole section here is the number of people that like chocolate and vanilla. So that means that this must be 82. Okay, so that whole section, this little part here, with this little line in it, it looks like an eyeball. This is, let me scoot up a bit, people who like chocolate and vanilla, right? So altogether, according to our data point, should be 100, right? But what we're doing is we're taking those 100 people and we're splitting them into 2 groups. The people who also like strawberry, right? That's the group who likes all 3. The people who like chocolate and vanilla and also like strawberry, and then the people who like chocolate and vanilla but don't like strawberry. So that's all we're doing. We're taking that 100 and splitting it into 2 groups here. And that's what we're going to do with each one of these positions. We're going to take that 18 away from each of these little overlaps. So let's keep that idea going with this spot, chocolate and strawberry. I'm going out of order here. Let's do vanilla and strawberry. Okay, vanilla and strawberry. So 52 altogether in this intersection of vanilla and strawberry. 52. But 18 of them already live here. So that means that there should be 34 people in this position who like vanilla and strawberry but not chocolate. So altogether 52 people like vanilla and strawberry, the 18 that live here and the 34 that live here. Okay. Now, this last intersection, 36 people like chocolate and strawberry, but 18 of them also like vanilla. That's why they live here. So the other 18 must be here. And why is it also 18? Well, because 18 and 18 makes 36. Okay. Now, this position, this last position in each of these circles, let me draw it. Let me draw one of the shapes. So for instance, this chocolate circle. Well, not a circle, this kind of shape. That's not including these two, or these three areas. So this thing here. This is people who like chocolate, but not anything else. This is the people who like chocolate, but not anything else. Another way to look at it is that if you take the whole circle of the people who like chocolate, all together, it should add to give 201. So we could look at it that way too. We could say, okay, take the chocolate circle. Whoops. Let me draw it on a separate piece and bring it over. So here's the circle of people that like chocolate. There we go. Just kind of pulling that piece out. So this is altogether, this is people who like chocolate, right? So altogether should be 201, that data point that we have back here. Okay, so what goes in this spot? The spot with no number written in it. Well, it should be some number so that when I add these three to it, we get 201, right? So in other words, take 201 and subtract these numbers to figure out what gets written right here. Okay. The people who strictly like chocolate, not anything else. That's the number that goes there. Okay, and what does that give us? 28, let's see. 100 minus 27 is 873, right? Let me change colors here. I believe it is 73. You could double check. Make sure that all four of these numbers add up to give 201. Is that right? I think that's right. Okay. Alright. Now, we're going to do a similar thing for vanilla. All together, this circle, with all these numbers in it, these three and then the missing one, should add to give 190. So let's see, that's 100. So these are 134. So I need an extra 56 out here. So 56 must only like vanilla. So these people strictly like vanilla, not chocolate or strawberry. Then over here, we've got strawberry, and how many people like strawberry? 85. 85 people like strawberry. So this plus this plus this plus whatever this is, excuse me, must equal 85. So let's see, this is 36 plus that, let's see, that's 40, 70, so there must be 15 people who only like strawberry. There we go. Almost completely done. The last thing that I can say is how many people are out here in the universal set. There were 400 people surveyed. How many people answered this survey with one of these three answers, or some combination, or all three? How many people answered the survey giving either chocolate, vanilla, or strawberry, or some combination? And how many people are left over? That's the number that will be out here. So, just to give myself a little bit of a break, I'm going to use a calculator to add all of these numbers up. Okay, adding all of these numbers up, these 7 numbers, that'll give me the total people that answered the survey. Plus 34, plus 15. Okay, so I'm getting, this is 296, but 400 people were surveyed. So that means there are 104 people who answered with something other than one of these 3 flavors. So they answered something else. Okay. Something else that wasn't considered in this survey, or at least in this analysis of the data. Okay. Let me ask some questions about the Venn diagram now that we have it. Now that we have the Venn diagram in front of us, let's see, let me go up a little bit more. Or better yet, I'll put it over here. Alright, how about this? How many people like chocolate or vanilla, but not strawberry? Think about that for a minute. How many people like chocolate or vanilla, but not strawberry? Well, that would be the 73 that strictly like chocolate, right? The 56 that strictly like vanilla, or the intersection of chocolate and vanilla, but not strawberry, which is that 82. That 82. So we're adding all the numbers, basically adding all the numbers that are not in the strawberry circle. Or out here, obviously. We're not adding that either. Okay, so that would be the answer to that question. Well, okay, you still want to add it up and actually get an answer. What would that be? Let's see, 2, 8, 11, okay, so 130, 200, I believe 211. My addition game does not feel strong today, so I apologize if I make any little addition errors, but you can definitely double check with a calculator. Okay. How about another question? How many people, let me think, let's see. Okay, how about a similar question? How many people like chocolate and strawberry, but not vanilla? Okay, so it seems similar. But I'm going to tell you it's not, actually. Obviously it's different because it's asking about different flavors. I've rotated here looking at chocolate and strawberry, but not vanilla. The answer is only 18. Why is it only 18? Why aren't I adding the 73 and the 15, kind of in a similar way to the previous problem? Well, because it's asking how many people like chocolate and strawberry. So that first statement, chocolate and strawberry, gets me into this position here, this little section with these 36 people in it. And then when I exclude vanilla, now I'm just in this little section. Huge difference coming from the word and versus the words or here. This is a union, right? This is like a union of chocolate and vanilla, but excluding the strawberry stuff. It's like a union, and this is like an intersection. The intersection of chocolate and strawberry, but discarding the vanilla. And that's actually literally how you would write this down. So if we want to get technical, let's number these for reference. Technically, like with symbols, instead of just by talking about it with this picture, this is how you would denote number 1. So number 1 would be the cardinality. Oh, I need to name them. We'll just call them C, V, and S, right? Chocolate, vanilla, strawberry. That's easy. Okay. Cardinality of C. Or what are we looking for? Sorry. How many people like chocolate or vanilla but not strawberry? Right. Okay. So the cardinality of C plus the cardinality of V. That's kind of like the first part of the inclusion-exclusion principle. But now we need to exclude all of the stuff that's in the strawberry circle, right? So cardinality of C is all of this stuff. Cardinality of V is all of this stuff, right? So we need to exclude a whole bunch of stuff here. First of all, the inclusion-exclusion principle would tell us to go ahead and exclude that extra intersection that we would get from adding C and V. If it was just these two sets and we added C and V together, we would get that intersection in there twice, so we would have to subtract it there. Okay, so I just realized I did make an addition error back here. So this should have been 83, which actually changes this over here too, not 73 but 83, and that will make that a 221. So alright, I don't think that affected anything else, okay, other than probably driving you crazy up until I found it. Okay, so looking here, this is just the inclusion-exclusion principle working here. That would be the union of C and V, so all of C plus all of V, and then taking out that part that would be double counted, okay, but now we also want to exclude these 3 positions, these 3 strawberry spots, right? We don't want to include anyone that also likes strawberry, right? Because this is number 1 where we're trying to exclude the people that like strawberry. So the very center spot, that's easy. That's the intersection of all 3. Now what about these 2 spots? What about those 2 spots? Well, one way to do it is to just take out the intersection of chocolate and strawberry. So we would say minus the intersection of chocolate and strawberry. But that's removing another one of these innermost intersections, so we could add one back in, and see, this is just going to get ridiculous. Because then finally the last thing would be to remove the intersection of chocolate and strawberry, right? No, sorry, vanilla and strawberry. But then also to add one of these back in, because that would be removing another one of these 18s in the very center. So, needless to say, writing it down technically, even though this may not be the most efficient way, gets very tricky. It's much better to have a picture in front of you. And just to see if this works, hopefully it does, plug in for each of these. What do we get? C is 201, that's from the original 201 like chocolate, plus vanilla is 190, minus C intersect V. C intersect V is 100, minus that middle intersection, which is 18, minus the intersection of chocolate and strawberry, which is 36, then plus that innermost intersection again, so we're here, minus the intersection of vanilla and strawberry, which is 52, but then plus that innermost intersection again, because we double subtracted it again. And let's see how this all works out. So 201 plus 190, minus 100, minus 18. Yes. Oof. Much trickier though. Much trickier. Yeah. The picture is definitely helpful. Now what about number 2? How could we technically write down number 2 here? Number 2 is much simpler. How many people like chocolate and strawberry? Okay, well, chocolate and strawberry is the intersection of chocolate and strawberry minus the people who like vanilla that are in this set, which would be that innermost exclusive group that likes all 3. So we're inside the group that likes chocolate and strawberry, which is this 36 people, but then we want to remove the people who also like vanilla, which are these 18. So we're getting 36 minus 18, which gives us 18. Much simpler than this one with the unions. When you're unioning sets that are interconnected like all of these, when you're taking unions, you really have to be careful about double counting things. That's why this got so crazy. Okay. Homework problems, just real quick for you to look at.